Welcome to the spoken tutorial on sound waves. In this tutorial, we will demonstrate standing wave and standing longitudinal waves apps. Here I am using Ubuntu Linux OS version 16.04, Firefox web browser version 62.0.3. To follow this tutorial, learners should be familiar with apps on physics. For the prerequisite tutorials, please visit this site. Using these apps, we will demonstrate the formation of a standing wave, explain the formation of nodes and antinodes, demonstrate harmonics of a standing wave, calculate the wavelength and frequency of standing waves. Use the given link to download the apps. I have downloaded the apps to my downloads folder. Right-click on standing wave reflection _en.htm file. Select the option Open with Firefox web browser. Standing wave app opens in the browser. In the green panel under reflection, we have two radio buttons, from a fixed end and from a free end. By default, reflection from a fixed end is selected. Below these radio buttons, you can see Reset and Start buttons. Start button is a toggle for start, pause and resume. At the bottom of the green panel, you can see Incidenting wave, Reflected wave and Resultant standing wave checkboxes. These checkboxes are selected by default. Click on the Start button. On the yellow panel, observe the propagation of a wave in a string. The red wave is the incidenting wave. The blue wave is the reflected wave. Observe that the reflected wave has a phase change of 180 degrees. Here, the incident and reflected waves have the same amplitude. Let us uncheck the reflected wave. If we uncheck any of the checkboxes, we cannot see the corresponding wave. Click the Reflected Wave checkbox to make it visible again. Click on the Pause button to stop the propagation of the waves. Here is the resultant standing wave. This wave is formed due to the superposition of incident and reflected waves. The resultant wave is the constructive superposition of the waves. Now I will show the superposition of waves in a step-by-step manner. Click on the Single Steps radio button to show the animation step by step. Here, a drop-down to show various time periods is seen. By default, it is T/8. We will leave it as it is. Now click the Resume button 3 times to show different superpositions. This is destructive interference of sound waves. Here, the waves are out of phase, so they subtract each other and form a straight line. Click on Resume button again. This is an intermediate superposition of waves. It lies between the constructive and destructive superpositions. Again click on the Resume button. This is constructive interference of the waves. This is the amplitude of the resulting standing wave. It is the sum of incident and reflected waves. For the time period T/8, one cycle takes 3 steps to complete. T/8 means 1/8 of the total time period. Let us select T/24 from the drop-down. Click on the Resume button continuously to see various superpositions. Observe that one superposition cycle now takes 5 steps. You can try other options given in the drop-down on your own. After the reflection from the fixed end, you can see A and N on the string. Here, N is a node and A is an antinode. Let us define a node and an antinode. Node is the point where the particles do not have any motion. Antinode is the point where the particle oscillates with maximum amplitude. As an assignment, using reflection from free end option, show the formation of standing waves. Observe the reflection by selecting various time period options. Explain your observation. Let us move on to Standing Longitudinal Wave app. To open the app, right-click on Standing Longitudinal Waves _en.htm file. Select the option Open with Firefox web browser. The app opens in the browser. Here is the information related to the app interface. Scroll down to see the interface completely. This interface shows a tube filled with air molecules. The blue dots inside the tube represent the air molecules. Here we can see two plots: displacement of particles and divergence from average pressure. X-axis represents the length of the tube. Delta X is the change in displacement of molecules from the equilibrium position. Delta P is the divergence from average pressure. Observe the pink and red waves. They show the instantaneous movement of air molecules. In the green panel, under the heading Form of Tube, we have 3 radio buttons. By default, both sides open radio button is selected. Next, under vibrational mode, we see 2 buttons, lower and higher. By default, the app shows the lowest vibrational mode. The lowest vibrational mode of the system is known as fundamental. Fundamental vibrational mode is the first harmonic followed by higher harmonics. We can change the length of the tube in this box. Length of the tube can be varied between 1 meter to 10 meters. The app calculates the wavelength and frequency based on the length of the tube. Click the higher button continuously. It shows 5 overtones for the 6 harmonical vibrations. Press F5 key on the keyboard to reset the app. Observe the motion of air molecules. Molecules in the middle of the tube do not displace from the mean position. Therefore, in the displacement of particles graph, node is in the middle. Observe that particles at the extreme positions are oscillating in and out. Here, particles oscillate with maximum amplitude. Therefore, antinode is present at the extreme ends of the x-axis. Let us move to the second graph. Observe the movement of particles inside the tube and graph simultaneously. In the graph, movement of the pink wave shows the changes in the pressure. As the particles move towards the center, they get compressed, so pressure increases. When they move away, pressure decreases. Under Form of Tube, select One Side Open Radio button. Observe the movement of particles in this form of the tube. Here, particles at the closed end are not moving. Therefore, the pressure is maximum at this end. Let us calculate the wavelength in this form of the tube. First, let us define wavelength. Wavelength is the distance between two consecutive peaks. Click on the higher button to show the first overtone. We have to calculate the wavelength of first overtone wave. Mathematically, we can write L equals to n by 4 of lambda. Here, L is length of the tube and lambda is the wavelength. N can take values from 1 to n. By rearranging the equation, we can write this as lambda equals to 4L upon n. Let us calculate the wavelength. The wavelength of the first overtone is 3/4 of the complete wave. Here, the value of n is 3. From the app, value of length of tube can be taken as L. Therefore, The calculated value of wavelength is 1.33 meter. This is the wavelength of first overtone mode of vibration. Now we will calculate the frequency of the wave. The number of complete oscillations per second is the frequency of a sound wave. It is measured in hertz. Frequency is calculated using the formula F equals to C upon lambda. Lambda is wavelength and C is speed of sound wave. The app shows the value or speed of sound wave as 343.5 meter per second at 20 degrees Celsius. Let us calculate the frequency of the same wave. Substitute the values for the above formula from the app. The value for the frequency is 258.27 Hz. This value is comparable to the value shown in the app. Make a tabular column to show the wavelength and frequency for 6 harmonical modes. Click on the higher button to go to next harmonic. Similarly, I have calculated frequency and wavelength for higher harmonics. As an assignment, change the length of tube to 8 meter. Calculate the wavelength and frequency for different vibrational modes. Another assignment, change the form of tube to both sides closed and explain the graphs. Let us summarize. Using these apps, we have demonstrated the formation of a standing wave, explained the formation of nodes and antinodes, demonstrated harmonics of a standing wave, calculated the wavelength and frequency of standing waves. These apps were created by Walter Fend and his team. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial project team conducts workshops and gives certificates. For more details, please write to us. Please post your timed queries on this forum. Spoken Tutorial project is funded by MHRD Government of India. This is Himanshi Karwanje from IIT Bombay. Thank you for joining.